This video is to go over briefly the binomial probability distribution. We're going to talk about what it is, the four conditions that need to be met, and how to use the table. So the binomial probability distribution, we use it when we have two outcomes. I have a couple of examples here, disease or no disease, available or not available. Another example would be right and wrong for a question, for example, in an exam. True and false questions, that would be also an example for a binomial probability distribution. The four conditions that we need to meet are, the first one is we need to have a fixed number of trials. If we don't have a fixed number of trials, if it just keeps going on forever, then it's not probably going to be a binomial probability distribution. The symbol for the fixed number of trials is going to be lowercase n. The trials need to be independent of each other. So a person performing a trial or a trial just happening does not necessarily affect the next trial that's going to happen. Each trial needs to have two outcomes, and that's in the definition of the binomial probability distribution. One of the outcomes is going to be labeled success or failure, and that's going to be in the context of the problem as well. Maybe success is there's no disease. Maybe success is they responded true to a question. It really, maybe success is finding a defective widget, like this one is defective, this one is not defective. We want to identify one that is defective so we can take it out of the process and we don't accidentally sell something that's broken. So what's determined as success and as failure really depends on the context of the problem. Another thing you need to remember is the probability of success is usually going to be given in the problem, but it needs to be the same at every trial. If something in the context of the problem tells you, oh, this is going to change at every trial, it's probably not going to be a binomial probability distribution. The symbol for the probability of success is going to be lowercase p. And we have the complement of that. So that's going to be Q, which is the probability of failure. And the way we find Q is just going to be 1 minus P. The other thing you need to remember is what X is. And that's going to be the specific number of successes. So we might be only interested in exactly 3 true questions, people that responded true to a question, or exactly 3 successes. Whatever we are interested in, it should be in the context of the problem, and that's going to be the specific number of trials, which is X, which is different than the fixed number of trials. So this is the binomial probability distribution table. This is the supplemental one that I added to Canvas. It actually has 7 pages. It has a couple more trials. This is a fixed number of trials, the n, and it's going to go down. It also has a couple more probabilities. That's why I added it to our Canvas. It can save you from having to use the formula one day. Here is going to be the number of successes, and that also is going to go down. It depends on where you are. So if the fixed number of trials is 5, that's going to go up to 5. If it's 6, the number of successes can only go up to 6 as well. The probabilities are here. That's P. And they go in this direction. They start to increase. Of course, it cannot go over 1 because probabilities cannot go over 1. But it does have a couple of other like decimals in here compared to the one to the textbook. And you don't need Q to be able to use the table. You do need to know what it means and how to find it. But for the table, you are good just by knowing the number of trials, the number of successes, and the probability.